Okay, so hello and welcome back. So let's now work through exercises or exercise 3.1. So exercise number 1, we have in the matrix number 1 we have a matrix A, which is basically this matrix over here. We have 2, 5, 19, -7. We have 35, -2, 5 halves, and 12. You have square root of 3, 1, -5, and 17, right? So you have this matrix, and you want to know, first of all, what is the order of this matrix. The order is basically, you have 3 rows here and 4 columns, so that's 3 by 4. That's a 3 by 4 matrix. Number 2 is the number of elements. Number 2 is the number of elements, and the number of elements is simply m times n. That is equal to m times n, which is equal to 3 times 4, which is equal to 12 elements. If you count, you will get the same number of elements. Number 3, you want to write the elements A of 1, 3. So A of 1, 3, which is the element that is in the first row, third column. First row, third column would be 19. And A of, for example, 2, 1 is the element which is in the second row, first column. Second row, first column would be 35. A of basically 3, 3 is the element in the third row, third column. Third row, third column is -5. A of 2, 4 is the element in the second row, fourth column, is 12, right? And A of 2, 3 is basically second row, third column. Second row, third column is 5 halves. So that is question number 1. Question number 2, if a matrix has 24 elements, so if a matrix has 24 elements, what's the possible orders it can have? What are the possible orders it can have? And what if it has 13 elements? So if you have 24 elements, basically the order of the matrix can be in basically any way that you can write 24 as a product of two natural numbers. So for example, 24, you can write it as, if you prime factorize it, you will get, first of all, you have 1 times 24. That's one way. And then you can write it as 2 times 12, 2 times 6, 2 times 3, and 2 times basically 3 is basically a prime number, right? So all the factors of I'm not talking about all the prime factors, but all the factors of 24, are basically 1. You have 1 and 24. So you can write 24 as 1 times 24. That would be basically, now we will talk about this in the next step. Then you can write 24 as, for example, 2 times 12, right? 2 times 12. Then you can write 24 as basically 4 times 6. 2 times 2 is 4, 4 times 6. 24 as 4 times 6. Then you can write 24 as 8 times 3. As 8 times 3. Now that all the possible orders in which you can write the matrix, therefore are. So of course you could write it as 1 by 24. You could write it as 24 by 1, because 1 times 24 is 24. 24 times 1 is 24. You could write it as 2 times 12. You could write it as 12 times 2. You could write it as 4 times 6, 4 by 6, or 6 by 4. Or you could write it as 8 by 3, or 3 by 8. I think that's all the possible ways that you can write it. Let me take a look at the solutions here, because I don't want to miss anything here. Okay, so I had to go to so many places in order to get the answers. The answers seem to be not to be basically in the copy of the book that I had, so I had to download them. But you have basically 1 by 24. You have 1 by 24, 2 by 12. You have 3 by 8. 3 by 8. You have 4 by 6, 6 by 4. You have 8 by 3. You have 12 by 2. You have 24 by 1. And then that's basically all of the different ways that you can write it. And the second part of the question, if you have only 13 elements, you know that 13 is a prime number. This is a prime number. Since it's a prime number, the only way that you can write 13 is that we can write 13 as basically 1 times 13, or you can write it as 13 times 1. Therefore, the different possible orders would be 1 by 13 and 13 by 1, right? These are basically the two different ways. Now that is basically question number 2. Question number 3 is, if a matrix has 18 elements, it's question number 3, has 18 elements, what are the possible orders it can have? All the possible orders. And what if it has 5 elements? 5 elements. So this is again the same thing. Prime factorize 18, you will get 18 is 1 times 18, or 2 times 9, or 3 times 3. Meaning that you can write 18 as 1 times 18, or you can write it as 2 times 9, 2 times 9, or you can write it as 6 times 3, or you can write it as basically 2 times 9, or 6 times 3. 6 times 3. So all the possible, basically, therefore all the possible all the possible orders would be 1 by 18 and 18 by 1 and 2 by 9 and 9 by 2 and 6 by 3 and 3 by 6, right? So 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6. Okay. Now, if it has 5 elements, again, 5 is a prime number, meaning that 5 can be written as only 1 times 5, meaning that all the possible orders would be 1 by 5 or 5 by 1. That is basically 2, right? So question number 3 is, question number 4 is construct a, you want to construct a 2 by 2 matrix, A of, basically A is equal to A of ij, whose elements are given by number 1, I plus j, A of ij, A of ij is equal to I plus j whole squared divided by 2, right? So you have a 2 by 2 matrix. Now a 2 by 2 matrix, you have basically all of these elements as A is equal to, for example, A of 1, 1, A of 1, 2, A of 2, 1, and A of 2, 2. So you have to calculate all of these elements using this relationship. Okay, so now let's calculate these 4 elements that we have here. So A of 1, 1 is equal to, so you have to basically calculate A of 1, 1 based on this relationship. And here you basically, when you write A of 1, 1, that means that your I is equal to 1 and your j is equal to 1, right? So therefore A of 1, 1 would be equal to, for example, 1 plus 1 raised to the second power divided by 2, which is basically 2 squared is 4, 4 divided by 2 is equal to 2, right? Now A of 1, 2, A of 1, 2 is equal to basically again 1 plus 2 raised to the second power divided by 2. That's 3 squared, 9 divided by 2, that's 9 halves, right? Now A of 2, 1 is going to be equal to, it's again the same thing because you're just simply adding these together, meaning that A of 1, 2 is going to be equal to A of 2, 1. So A of 1 is equal to A of 1, 2 is equal to 9 halves, because you would write this as basically 2 plus 1 raised to the second power divided by 2 based on the formula. And so you have 3 squared divided by 2, which is equal to 9 divided by 2, right? And then you have A of 2, 2, which is equal to basically 2 plus 2 raised to the second power divided by 2, which is equal to 4 squared, which is equal to 16 divided by 2 is equal to 8, right? So that means that your matrix becomes basically A of 1, 1 becomes 2, A of 1, 2 becomes 9 halves, A of 2, 1 becomes 9 halves, and A of 2, 2 becomes 8. That would be your matrix, right? And this was question number 4. So 2, 9 halves, 9 halves, and 8. This is correct. Now again, Now we have a couple more parts here. This question has actually a couple of parts, meaning that you have again you want to construct a so let me create a new layer here. So 8, and again you want to construct a 2 by 2 matrix, which we can take as A equal to A of ij, and the elements are given by A of ij is equal to basically I by j, right? So you have basically if you write out your matrix, you would have basically A as A of 1 1, A of 1 2, A of 2 1, and A of 2 2, right? So then A of 1 1 would be equal to 1 divided by 1 based on this formula, which is equal to 1. A of 1 2 would be equal to 1 divided by 2, which is, well, which is 1 divided by 2. A of 2 1 would be equal to 2 divided by 1, which is equal to 2. And A of 2 2 would be equal to 2 divided by 2, which is equal to 1. And therefore your matrix becomes basically A of 1 1 is equal to 1, A of 1 2 is equal to 1 half, A of 2 1 is equal to 2, and A of 2 2 is equal to 1, right? So that is 1 1 and 1 half and 2. So this is the correct answer. Again, the third part of the question number 4 is, this is again question number 4, part 3. So you want to construct a 2 by 2 matrix, in which basically, let's call it A, for example, A of ij, where the elements are given by A of ij is equal to I plus 2j raised to the second power divided by 2, right? So again you have your matrix as A, and that is A11, A12, A21, and A22. And so A11 is the same thing as basically 1 plus 2 times 1 whole raised to the power 2 divided by 2. So that is 2 times 1 is equal to 2, 2 plus 1 is equal to 3, 3 squared is equal to 9, that is 9 halves. A12 is equal to basically 1 plus 2 times 2 whole raised to the second power divided by 2. So that is equal to 4 plus 1 is equal to 5, 5 squared is equal to 25, that's 25 halves. A21 is equal to basically 2 plus 2 times 1 whole raised to the second power divided by 2. Now this is 2 plus 2 is equal to 4, 4 squared is equal to 16, 16 by 2 is equal to 8. And A22 is equal to basically 2 plus 2 times 2 whole raised to the second power divided by 2. This is 4 plus 2 is equal to 6, 6 squared is equal to 36, 36 divided by 2 is equal to 18. And then your matrix becomes basically 9 halves, 25 halves, 8 and 18, right? Which is the correct answer. Okay. Question number 5 again, it's about constructing matrices. And this time we want to construct a couple of 3x4 matrices. And the element is given by, for example, A of ij is equal to, for example, 1/2 the absolute value of -3i minus j. And that is basically that. So again, a 3x4 matrix, you will get, the matrix would look something like this. For example, if I call it A, that would be basically A of 1, 1, A of 1, 2, A of 1, 3. You have a 3x4. That means that you have 3 rows and 4 columns. So you will get another column here. And then you have A of 2, 1, A of 2, 2, A of 2, 3, and A of 2, 4. And then you have A of 3, 1, A of 3, 2, A of 3, 3, and you have A of 3, 4. And that is basically, that would be the matrix. Now, you need to, of course, we need to calculate each of these one by one and then construct the matrix using that. Okay, so now let's calculate these one by one. So A of 1, 1 is equal to, for example, 1/2 times the absolute value of -3 times. So here your I is equal to 1, your J is equal to 1. So times 1 minus 1. Now this is -3 minus 1, which is equal to -4. The absolute value of -4 is 4. 4 divided by 2 is equal to 2. A of 1, 2 is equal to 1/2 of basically the absolute value of -3 times 1 minus 2. Now this is equal to -3 minus 2, -5, so that becomes +5. That's 5 by 2. A of 1, 3 is equal to 1/2 of the absolute value of -3 times 1 times minus 3, which is equal to, so this is -3 minus 3 is -6, so that becomes +6. 6 divided by 2 is equal to 3. A of 1, 4 is equal to 1/2 times the absolute value of -3 times 1 minus 4, which is equal to -7, so +7, 7/2. Then you have A of 2, 1. A of 2, 1 is equal to 1/2 of the absolute value of -3 times 2 minus 1, which is equal to -6, -7. -7 becomes +7, 7/2. A of 2, 2 is equal to 1/2 of the absolute value of -3 times 2 minus 2, which is equal to -6, -8. +8 divided by 2 is equal to 4. A of 2, 3 is equal to 1/2 times the absolute value of -3 times 2 minus 3, which is equal to -6, -11, 11 by 2. A of 2, 4 is equal to 1/2 times the absolute value of -3 times 2 minus 4, which is equal to -6, -10, +10, 10 divided by 2 is 5. Then you have A of 2, we have over here 2, 1 through 2, 4. So you have A of 3, 1 is equal to 1/2 times the absolute value of -3 times 3 minus 1, which is equal to -9, -10. 10 divided by 2 is equal to 5. A of 3, 2 is equal to 1/2 times the absolute value of -3 times 3 minus 2. Now this is 9, -11, 11/2. And then you have A of 3, 3 which is equal to 1/2 times the absolute value of negative 3 times 3 minus 3, which is equal to negative 9, negative 3, negative 12. 12 halves is equal to 6. And a of 4 is equal to 1/2 times the absolute value of negative 3 times 3 minus 4, which is equal to negative 9. Negative 9, 9 plus 4 is equal to 13, negative 13, so 13 halves. And so your basically matrix becomes 1, 2, 1, 3, 1, 4, so you can write them in the order as rows. So 2, 5 halves, 3, 7 halves, and then again this is the second row, so 7 halves, 4, 11 halves, and 5. And then you have here basically 5, 11 halves, 6, and 13 halves. And that is a 3 by 4. That is a 3 by 4 matrix. Take a look at the answer 1. This was question number 5. Oh, as it turns out, I have made a mistake here actually. This was supposed to be a positive. So, but basically, that the process, I'm not going to solve this again, but you can do that, of course, on your own using the same process. You know how to do it. Actually, the original question in the book was, it seems that it's been 1/2 times the absolute value negative 3i plus j. So I have, by mistake, I have written minus j, and then the whole thing is now, of course, different. But the process is basically the same, right? Now, the second part of this question, again, you want to construct a 3 by 4 matrix. 3 by 4 matrix, and the elements are given by A of ij is equal to 2i minus j. So a 3 by 4 matrix would be, for example, A, and you would have basically A of 1, 1, A of 1, 2, A of 1, 3, and A of 1, 4. You have 4 columns. And A of 2, 1, A of 2, 2, A of 2, 3, and A of 2, 4. And A of 3, 1, and A of 3, 2, A of 3, 3, and A of 3, 4. And so now you have basically 3 rows and 4 columns, right? So calculating basically these, you will get A of 1, 1 is equal to 2 times 1 minus 1. That is 2 minus 1 is equal to 1. A of 1, 2 is equal to 2 times 1 minus 2, which is 0. A of 1, 3 is equal to 2 times 1 minus 3 is negative 1. A of 1, 4 is equal to 2 times 1 minus 4, which is equal to 2 minus 4 is negative 2. A of 1, 5 is equal, there is no A of 5, I'm sorry. A of 2, 1 is equal to 2 times 2 minus 1, which is equal to 4 minus 1, which is equal to 3. A of 2, 1 is equal to 2 times 2, this is 2, 2, 2, so minus 2 is equal to 4 minus 2 is equal to 2. A of 2, 3 is equal to 2 times 2 minus 3, which is equal to 4, which is 1. A of 2, 4 is equal to 2 times 2 minus 4, which is equal to 0. Then you have A of 3, 1, which is equal to 2 times 3 minus 1, which is equal to 6 minus 1 is equal to 5. A of 3, 2 is equal to 2 times 3 minus 2, which is equal to 6 minus 2 is equal to 4. And a of 3, 3. A of 3, 3 is equal to 2 times 3 minus 3, which is equal to 6 minus 3 is equal to 3. And a of 3, 4 is equal to 2 times 3 minus 4. 6 minus 4 is equal to 2. And so your matrix becomes basically 1, 0, negative 1, negative 2, 3, 2, 1, 0, 3, 2, 1, 0, and 5, 4, 3, 2. 5, 4, 3, 2, and that's the matrix that we were looking for. 1, 0, negative 1, negative 2, 3, 2, 1, 0, 5, 4, 3, 2, and that's the correct answer. The previous one, of course, you can use the same, basically the same methodology and the way that we solve the problem together to solve that problem. Now, question number 6, we have find the values of x, y, z from the following equation. So you have, for example, 4, 3, x, 5. This is a matrix, and that is equal to y, z, 1 and 5. So the corresponding elements are, of course, equal because the matrices are equal. So you can say that y is equal to 4, z is equal to 3, x is equal to 1, and, well, 5 is equal to 5, which you don't have to really write it. The second one is x plus y is x plus y, and then you have 2, and then you have 5 plus z, and then you have x times y. So that is a matrix that you have, and then you have another matrix 6, 2, 5, 8. So you know that basically x times x plus y is equal to 6, and x times y is equal to 8. So from these you can calculate, for example, you can write from this, you can write basically x is equal to 6 minus y, and then put it in this equation, meaning that instead of x we can write 6 minus y times y is equal to 8. If you multiply, you'll get 6y minus y squared is equal to 8, which means that negative y squared plus 6y minus 8 is equal to 0, which means that y squared minus 6y plus 8 is equal to 0. And then you can solve this equation for y. And you can basically rewrite the middle term of this equation as so the way that you can solve it is that you need to write, basically you have a coefficient 1 here and this 8 over here. So 8 times 1 is equal to 8. Now if I write 8 as 2 times 4, then it seems that negative 2 and negative 4, if I add them together, I'll get a negative 6. And then if I multiply these two together, I'll get a positive 8, which is what I started with. That means that I can use these two numbers to rewrite this equation. So I write it as y squared minus 2y minus 4y plus 8 is equal to 0. Then I will, for example, take these two terms together and these two terms together. From these two I can take a y out, y minus 2. From these two I can take a negative 4 out, so y minus 2 is equal to 0. Now from these two I can take y minus 2 out and write this as y minus 4 is equal to 0. That means that either y is equal to, that means that basically y minus 2 is equal to 0, or y minus 4 is equal to 0. This means that y is equal to 2 or y is equal to 4. y is equal to 2 or y is equal to 4, right? Now, if I can accept both of the answers, because if y is equal to 2, then if y is equal to 2, then x is equal to 4, and if y is equal to 4, then x is equal to 2, right? So here we have two possible values for y, 2 and 4, right? So if y is equal to 2, then if I use this equation, meaning that, let's say that y is equal to 2, then x times y is equal to 8. Then x times 2 is equal to 8, that means that x is equal to 8 by 2, which is equal to 4. So if y is equal to 2, x is equal to 4, and vice versa. So you can say that either x is equal to 4, y is equal to 2, or x is equal to 2, y is equal to 4, both will satisfy the system of equations. So we have no problem with that. As far as we are concerned here, we have no problem with that. And then since 5 plus z is equal to 5, then that means that z is equal to 0. Z is equal to 0. The answer here is basically x is equal to 1, y is equal to, this is number 6, part 2. So you could have two cases, meaning that you can separate these for the sake of simplicity. You can say that either x is equal to 4, y is equal to 2, and z is equal to 0. Or you could say that basically x is equal to 2, and y is equal to 4, and z is equal to 0. Both are possible, right? So that is basically that. Now the next thing that we have here is part 3 of this exercise, which is 279. So part 3 is, we have a matrix x plus y plus z, and then we have x plus z, and then we have y plus z, and that is basically a column matrix that we have. And then the values are 9, 5, and 7. 5 and 7, right? So in order to solve this, now this is a little bit tricky, because here you have 3 unknowns, here you have 2 unknowns, and then here you have, so here you can write x in terms of z, for example, or z in terms of x. Here you can write y in terms of z or z in terms of y, and then put one of them in the other equation, eliminate the other one, and then and then do the same thing over and over again until you will solve all of the equation for all of the 3 unknowns, meaning that x plus y plus z is equal to 9, and x plus z is equal to 5, and y plus z is equal to 7, right? Now if I call these, for example, 1, 2, and 3, for example, I can take 2 and write x is equal to 5 minus z, right? 5 minus z. And then put this in 1. So then 1 becomes basically in 1, instead of x I write 5 minus z. So 5 minus z, that is x. And then I can write plus, and then y over here, I can write it in terms of z, meaning that I can take 3 and write y is equal to, or z is equal to, or y is equal to basically 7 minus z, right? 7 minus z. So if y is equal to 7 minus z, I can, in 1, instead of y, I can write 7 minus z. So plus 7 minus z. And then there is a z over here that I can simply write it, and that is equal to 9. Now I have only one unknown here. So I can simplify z and z here, and so that becomes basically 5 plus 7 is equal to, I can basically write 5 plus 7 is equal to 12 minus z is equal to 9, and therefore negative z is equal to 9 minus 12 is equal to negative 3, z is equal to 3, right? Now that I have this, I can solve for x, for example. I can use 2 and write x plus, for example, 3 is equal to 5. That means that x is equal to 2. And now that I have these two, I can solve for y, meaning that I can use 1 and write, for example, 2 plus y plus 3 is equal to 9. So that means that y is equal to 4. Which means that x is equal to 2, y is equal to 4, and z is equal to 3. That is, I suppose, the answer here, if I'm not mistaken. 2, 4, and 3, yes. Okay. This was question number 6. Question number 7, we have find the value of a, b, c, and d from these equations. So you have a minus b, you have 2a plus c, and you have 2a minus b, and you have 3c plus d. 3c plus d. That is a matrix. 2a plus c, 2a minus b, 3c plus d. That is equal to negative 1, 5, 0, and 13. Okay. Now, I can find a and b from these two. And then if I find a and b, then I can find c over here as well. Because if I have a, then I can solve for c. If I have c, then I can solve for d here, and then the problem will be solved, right? So I can write a minus b is equal to negative 1, and 2a minus b is equal to 0, right? Call it, for example, 1 and 2. And then to eliminate b, I can multiply any of these equations by a negative 1. For example, I can say, for example, 1 times negative 1, we have negative a plus b is equal to positive 1, and then I write 2 as it is. So that would be 2a minus b is equal to 0, then b will be eliminated. Add these two together, you'll get a is equal to 1, right? If a is equal to 1, then you can put it in, for example, in 1, and you will get 1 minus b is equal to negative 1, which means that negative b is equal to negative 1 minus 1, which means that negative b is equal to negative 2, which means that b is equal to 2. Now I have a and b, so I can solve for c. I know that 2a plus c is equal to 5, and a is equal to 1. So 2 times 1 plus c is equal to 5. 2 plus c is equal to 5. C is equal to 5 minus 2 is equal to 3. Now that I have c, I can solve for d. I know that basically 3c plus d is equal to 13. And so 3 times 3 is equal to 9. 9 plus d is equal to 13. D is equal to 13 minus 9 is equal to 4. And therefore a is equal to 1, B is equal to 2, C is equal to 3, and D is equal to 4. That is hopefully the right answer. That is number 7, 1, 2, 3, and 4. Okay, so that was number 7. Number 8, we have basically A is a matrix, A equal to basically A of ij of the order m by n is a square matrix if A, choice A, m is less than n. Choice B is m is greater than n. Choice C is m is equal to n. And choice D is none of the above. None of these options. Of course, the right and the correct answer is this one, because by definition a square matrix is a kind of matrix where the number of rows and the number of columns are exactly the same. So basically that is the correct answer there. And then you have question number 9. You have which of the given values of x and y make the following pair of matrices equal. So you have basically two matrices, 3x plus 7 and 5 and y plus 1 and 2 minus 3x. So that is one matrix. You have another matrix, 0, y minus 2, 8, and 4. This is another matrix that you have. You want these matrices to be equal. That means that basically 3x minus 7 has to be plus 7 has to be equal to 0, and y minus 2 has to be equal to 5, and then over here we have again the same story. Here basically this gives y is equal to 7, and over here y would be, again, if you try this, y plus 1 is equal to 8. That gives you again y is equal to 7, and 2 minus 3x is equal to 4 gives you negative 3x is equal to 2, which means that x is equal to negative 2/3, right? Oh, which is a contradiction, because if you try this one, you will get 3x is equal to negative 7, and then which gives x is equal to negative 7/3. So I'm going to say it is not possible. It is not possible because, and that is choice B, because here I'm getting x is equal to negative 2/3, here I'm getting x is equal to negative 7/3, so these two matrices cannot be equal in the first place. And question number 10 is basically the number of all possible matrices of order 3 by 3 with each entry 0 and or 1 is. So the number of all possible matrices of order 3 by 3 with each entry 0 or 1. With each entry 0 or 1 is, now that the answers are, or the choices are 27, B is 18, C is 81 and D is 512. Now this needs a little bit of thought. Ooh, I don't really understand the question. The number of all possible matrices of order 3 by 3. With each entry 0 or 1. Let me think about this. Okay, so about this question, well, this is an interesting question, and well, I can just answer it just like that this is the permutation of this and that, but I want to solve this question in a more fundamental way, and that needs a little bit of time and background, essentially about permutations, a couple of examples and so on and so forth, so that we understand it. And therefore I will address this question separately somewhere else, hopefully in this course. I'll have to find a good way to explain it. I mean, basically, first of all, I have to gather my own thoughts and see how I can do it. So now this was basically this was exercise 3.1. This was exercise 3.1. And then in the next video, we will talk a little bit about operations on matrices. I'll see you in the next video, and thank you.